we're going to look at DeMar's theorem, which is basically taking a complex number in trig form and raising it to a power. And then, just like in most things in math, if you can do things one way, you should be able to do the reverse process. We're also going to take a look at, instead of just raising it to a power, taking the root of a complex number. Now, DeMar's theorem says if you take a complex number raised to a power when it's in trig form, basically all you have to do is apply that power to your r and multiply that power times your angle. That's what DeMar's theorem says to do. Well, we need to start out then with this. The first thing we need to do is to get it in the trig form. Well, here, okay, we got a problem here. Just a second. Okay, sorry about that. We had the triangle going the wrong way. I'm not sure what happened there, but I just messed up. So we got to put it in trig form. To begin with, we know we're going -2 root 3 to the left, and then we know we're going 2 units down. To put it in trig form, it's easiest to go ahead and plot your angle, or not your angle, your complex number, which is technically just a dot right here, but we draw ourselves a triangle, so it's easy to find r and your angle. Well, you want to use your Pythagorean theorem. This side squared plus this side squared equals this side squared, and so when you do that, you get r to be 4. Well, now we want to go ahead and find your angle. To find your angle, once again, you want to go tangent. So you go tangent of your angle equals your opposite over your adjacent. Well, the negative root 2's drop, you get 1 over root 3, which is a root 3 over 3. That's one you're supposed to have memorized, so you should go ahead and work that out, and then you would get your angle then to be 7 pi over 6. So your angle in trig form is an r of 4, cosine of your angle 7 pi over 6 plus I sine of 7 pi over 6. Now we got to still raise it to the 5th power. Now, when we're dealing with DeMar's theorem, it says you got to take and apply that exponent to your r. Then you got to take that r, multiply it by your angle. And then all we have to do is simplify. So we get 1,024 in front. Multiply your angle, 35 pi over 6. Well, our 35 pi over 6 is really the same as an 11 pi over 6. Because this is more than 2 pi, and remember, if you go around more than once, you just start to repeat your value. So you just go ahead and subtract 2 pi, which is really 12 pi over 6. It's still more than 2 pi, then subtract another 2 pi, which is 12 pi over 6. You get down to your 11 pi over 6. So this is your answer in trig form. However, we started out not in trig form, but rectangular form, so we want to go ahead and convert this back. Evaluate your cosine of 11 pi over 6, which is root 3 over 2. Evaluate the sine of 11 pi over 6, which is a negative 1/2. Then you want to go ahead and distribute through. So this is your answer in rectangular form. Well, we now want to go ahead and take a look at roots of complex numbers. Keep in mind, DeMar's theorem is used for raising it to a power, where this one is for taking roots. I've seen a lot of people mix these up on their tests, so be very careful of that. Here's your formula. You're going to just have to work with it. It says basically to take the nth root of a complex number, you take the nth root of that r, and then to figure out your angle, you got to use this formula here. R and theta are your answers you get from putting it in trig form. N is the root you're taking. K is a number that starts at 0, goes all the way up to 1 less than the number of roots you have. So let's go ahead and work this out. We're going to start out with finding the 4/4 roots of 16. We want our answers in rectangular form and in trig form. Once again, you need to first of all get it in trig form before you can do anything. Well, it's really a 16 plus 0i, which means you're going 16 units to the right and you're going up and down nothing. So you really just have this point out here. So when you look at that, your just distance is just 16 to the right, so r is 16. Your angle going straight to the right is 0. So n then is the root you're taking, which is your 4th root. And then k is 0, 1, 2, 3. You always start at 0, go up by 1 at a time until you get to 1 smaller than n. So now we're going to go ahead and plug that in. Plug in n, plug in r, plug in theta. We're not going to plug in k yet, and plug in n. That's why it's always nice to write r, theta, n, and k over here on the left-hand side, because we've got to plug it all in. So it's easiest to have all those figured out ahead of time. Then once again, your angle over here is the exact same thing. So all I'm going to do is take this formula here and simplify it. The fourth root of 16 is just 2. If I add 0, it doesn't do anything. So that really disappears. And then your 2 pi over k, 2 pi k over 4 reduces down to a pi k over 2. So, sorry about that. Now we need to go ahead and start plugging in the values of k. Well, all we're going to do is plug 0 into our formula. Plugging 0 into our formula, 0 times pi, that drops out, giving us 0. So here's our answer in trig form. Well, to get the rectangular form, once again, you evaluate your two trigs, the cosine of 0, sine of 0, distribute through, you get your first answer to be 2. Now we want to come back and plug in 1, because that's the next number up in k. So you plug 1 in for each one of these k values, so then you get a pi over 2. That's your answer in trig form. Once again, evaluate the cosine and sine of pi over 2. Distribute through to be able to get your rectangular form. Now you want to come back, take your 2, plug it in up here. 2 pi over 2, well, that's just pi. Evaluate, or this is your answer in trig form. Get your rectangular form, evaluate each one of your trigs, distribute through. Now we want to go ahead and plug in 3. Plug in 3 for your k value up here. This is your answer in trig form. Distribute through. And then we get our answer in rectangular form. So here are our 4 fourth roots in trig form. Here are our 4 fourth roots in rectangular form. Well, we want to do the same thing over here, but the first thing you want to do is go ahead and get this into trig form. Once again, it's easiest to just go ahead and graph that. Once again, it's telling you to go 4 root 3 to the right and go down your negative 4. So it's really just this point here. And in this case, we're looking for our 3 third roots. So once again, you want to find r, theta, n, and k. Well, r, once again, you use your Pythagorean theorem. This side squared plus this side squared equals this side squared. And in this case, you would get 8. Now, remember when you're doing that you need to take and square your 4 and square your root 3. So you get a 4 squared times a 3 because your square undoes your square root. So you get a 16 times a 3, or a 48 when you square this side. Then when you want to go ahead and find your angle, remember you want to use tangent because you have your opposite over your adjacent. Your 4's drop, leaves you with a root on the bottom, so you rationalize it. You get a negative root 3 over 3. That's one you're supposed to have memorized, so you go ahead and work that out, and you get 11 pi over 6. And once again is the root you're taking. K starts at 0, goes up to one number less than n, so 0, 1, and 2. Now we're going to go ahead and plug those into our formula that we have up here in the upper right. Plug in n, r, and theta. Cube root of 8. There's your theta. Don't plug in k, n, and so you're going to get the same thing. Now I'll go to another video to finish this.